In this, our third time around with the pedestrian crossing exercise, we're going to broaden out our possibilities associated with how long it takes us to get across the intersection or across the street. Right? And so now we're going to first look at that the pedestrian requires 10 seconds to get across. We'll follow the rule that we're going to begin immediately after a car passes and see how we handle that one. And of course, in this very first case, it's straightforward that the only way we can get across are if the traffic gaps are 12 or 15 seconds. Otherwise, we don't make it. Right, so this is just like the very first example, Intro 2.1, with the exception that now we only have t equal to 12 and t equal to 15 into the bargain. So 2 nights plus 1 night equals then a total of 1/3 chance that we're going to make it across safely. Right, so that going from 8 seconds to 10 seconds had a significant influence on our chance of getting across safely. This next part of it, though, now is to say, okay, wait, there's more than just one possible time that it might take to get across. And so we have 8, 10, 13, and 16 seconds as our times to get across. Right? And these have relative frequencies of 15, 3, 1, and 1. So a pedestrian, any random pedestrian comes up to the crossing they want to go across, and they might take 8 seconds, 10, 13, or 16 to get across. Right? And so our approach here is very similar to what we've been doing before. First, we take that frequency ratio that we have, 15 to 3 to 1 to 1, for our possible outcomes for the crossing time, and convert them into a probability. So the odds that we're going to reach into the crossing time bag and pull out one that says 8 seconds on it is 3/4, right? And 15% chance that it says 10, and 5% chance that's either 13 or 60, so to speak. Right. Now, when we go to look at, ultimately we want to calculate what's the odds of safe crossing. And so first we'll start with, well, what's the likelihood of safe crossing given how long it takes to get across, right? And we've already done this calculation. The specific one was in example Intro 2.1, and that gave us a 67% chance if it took us 8 seconds to get across. And we started at the beginning of the time interval. Right? For the 10-second one, we just crossing time, we calculated that it would be 33% chance. For a 13-second time to cross, the only gap that comes to us that's long enough is the 15-second one, and so we have a 1 night's chance of reaching in the bag and getting that particular one, right? So that's a different bag that we're reaching into than it is the one for how long it takes us to get across. Right? This is only given how long it takes us to get across. What's the odds that we make it if we start at the beginning of the gap? Right, so that's 1/9.111, and that's why when you see probability of safe crossing given that it takes us 16 seconds to get across is 0. That's too long, and we never have a time gap that's large enough for us. All right, so now we go to the total probability rule that we're going to look at all the various combinations of possibilities. Probability of safe crossing now is going to equal to the sum of the conditional probability times this marginal. Right, so probability of safe crossing given the time to cross, that's up here, and this is the probability of the time to cross. So we're weighting all of these numbers up here by the likelihood of the conditioning event. That's really what's happening here. So 67% chance that we make it if it takes us 8 seconds times 3/4 chance that we have an 8-second gap, and so on and so forth, gives us a 56% chance of making it across before. And that's, of course, smaller than our original problem, which was given that it takes us 8 seconds to cross. And that's because we've weighted here all the different likelihoods that our population has of taking larger times across. So that's not really surprising. We looked at a different kind of population for the crossing aspect here. Right? And also note that ultimately we were using sort of a nested kind of sets of conditioning events as we went about approaching this. Now, we could also begin to look at this as not discretized time. We could allow both the time to cross as well as the time gaps themselves, instead of being specific individual values that we've got here. Instead, we could let them be real numbers as they are in real life. And when we do that, the approach that we use in terms of the notation that we have of this kind of statement will be the same, but the summations instead now will become integrals. And we'll also, in addition to that, have to slightly redefine these probability masses, and what they'll actually become is probability densities, and we'll get into that in module 3. Right, so that's a little ways away before we get to that. And depending on what the mathematical statements look like inside the integrals, the math might actually be harder, or it might actually be easier depending on what the form of the distributions are.